Hey, welcome back, everyone. So it's been brought to my attention that all of the things I point out in videos are all due to the sun. And this is by an opinion of one of the YouTube watchers. Uh, he left a few comments. He says that everything I point out are anomalies, and mostly due to the saturation of the camera due to the sun being so bright. Now, I did ask him, which he never did answer, what about when the sun is covered? And I'm just going to assume that that question didn't exist or something in his mind because, or he just couldn't answer it, one of the two. But today I think we'll do something different. So it's the sun saturating the camera software and it's really bad. Okay, we'll go with that for 2 seconds. Tonight we're facing east at sunset. So we'll find out if all these anomalies, shadows, and blah, 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 are all just that, anomalies. Let's find out. Because we know how light looks. So we'll look at a few normal sunrise places at sunset. Now, as you can see, the clouds behind the clouds are moving in a different direction, and they are darker in a shadow. Let's just keep going with this. The lower the sun gets, the brighter they get. Okay, that matches up with what I've been talking about. As you can see, the upper atmosphere seems to be going a different direction. We have our little clouds down here and whatever and however far away those are. But we'll just keep trucking along here and see if we don't not get anomalies this time. Okay, so far I'm already seeing a great big shadow over here coming in. Not to mention that is what I've been pointing out this whole time. And as we're cruising right along, none of our clouds are illuminating. We have a backside of darkness over here. The sky doesn't even look like it's the right color. We have light coming across the bottom, squeezing through. We have clouds up in the upper area that aren't illuminated yet. Now, don't you think that the sunshine would come over up through here? You know what I mean? Instead of pinching all the way along the horizon line, all the way around to the east side, because yes, this is facing east. And as the sun gets lowered, the ray of light keeps getting brighter and everything up here keeps getting darker until the sun gets below horizon. And you can see over here something's illuminating already. This is all dark. This is a crescent illumination. See how it's only lit on one side going up? Imagine it's going up this way. And this is all dark side. See how it's getting brighter and brighter now? It's crescent illuminating. We got light going all the way across the bottom and starting to veer upwards as it wraps around the bottom of the planet. See how it stays crescent illuminated with light still pinching down below? See how it's reflecting that blue light like I was talking about? So with no direct sunlight on the camera, we can see that these weird, strange things are still happening regardless if the sun is staring the camera in the face or not, as you can see. All right, let's look at this one. This is facing east as well. We will look at sunset. Now, already, you can see where the sun is. It's back behind the camera. And we're still getting the variations of blue in the sky. We're still catching the shadows starting to come down due to the lack of light. You can see the shadows just streaking. And all this behind here is staying darker. Now the sun is getting lower. Everything is starting to illuminate. All of a sudden the sun hits some clouds finally as it gets below them. That doesn't change this circular shadow that's being cast. Now that the sun has gotten down, the sky finally begins to illuminate. See the different color of, and it's also on a tilt like a planet would be. See what I'm saying? See how the light is choosing to go all the way underneath the sky? And it illuminates finally as it goes across. See how the light's being pinched through there? That's not an anomaly. That's a fact. There's no oversaturation. There's no any of that other mumbo jumbo you tried to spout out. Nothing is due to the sun, as could be seen right there. All right, we'll go somewhere else and watch the sunset there as well. This is normally a sunrise location. As you can see, the sun is behind us. So there's no oversaturating, there's no camera malfunctioning, and all that other nonsense. And we're still seeing shadows creeping across the sky from what's behind us in the sky. Now, as you can see, the light is starting to be forced down underneath all of this area. And as you notice, all this area is getting darker. But as the sun gets lower, it will start to brighten up. See how the sunshine is pushing across the sky? See that? None of this is oversaturated or anomaly. As you can see the light, how it's being pinched in between us and the sky. See how the light is pinched, already illuminated the entire sky before the sun ever comes up. See how it's only illuminating the bottom part of it as the sun comes up. Amazing how there's clouds that go all the way across the sky that are illuminated. long before the sun ever comes up. And notice how the sunlight's being pinched off right here and straight across over here. Now see, let's back up. See the difference between no sun hitting the lens and sun hitting the lens, but you can see the light streaking across the sky. You notice how that happens? How the sun goes up and then turns right after being pinched off? And yet none of this back in here is illuminated. Sun's right there. You'd think there'd be light coming through the holes, but there's no light coming through right here. There's a rounded cast shadow. And remember, cast shadows during the day are going to be subtle and light. You got the one that's going all the way across. See, this is still a cast shadow. Still a cast shadow. This is sunset. You notice how the sun's light is still coming through everything above. It's because the light is being pinched in between us and the sky. Wow. All the reflections that he says are saturated, you know, anomalies. And you were saying? Lots of reflecting going on here. I don't know, folks. What do you think? For looking east at sunset, that's a whole lot of light coming through from the top of the clouds up there. For the sun being behind the camera. Yeah. As far as the anomalies and all that mumbo jumbo he was talking. Yeah. Now what? What do you want to blame it on now, guy? Huh? There's that bluish light. And it's from above the cloud to the sunrise. See how the light's deflecting? Okay, now we see that the sun is coming up here. I'm going to spare myself the white pages and editing them out. And then we'll go straight to sunset. Okay, as you can see, there's still great big shadows going across the sky. Cast shadows. And also when there's less light in the sky due to the cast shadows, where there is light, the shadows are very sharp and focused, not blurry like you would expect to see when the sun is in the sky. Okay, there's some more of that anomaly reflecting light in the sky. As you can see, the light is now beaming all the way across behind the clouds, and now we have the sun going down in the east, which is behind us. As you can see, the light pinching it now across the sky in a rounding sort of way. See how it rounded up with the light? See, my theory is normally when we're looking up, or we used to be looking up, we had a layer of clouds. I always called it the ceiling, but there was a cloud layer. Now, since then, there's been a lot more layers, distant layers, and I think they're visible right now due to the fact that there's a lot less light, which makes things a lot easier to see in the sky. Well, there's the light again, pinching across the entire sky. See that? How it's beaming. Now, don't mind this little spot right here. That's just dirt on the lens. Now, we are facing east at sunset. See what's starting to come into view here? That's reflecting sunlight. It's even crescent illuminating. See how it's going up. So, yeah, there's that. And here's what it looked like during sunrise. If you really want to see what it looked like then. See? Sunrise. Not sunset. You see how this is rounding? You got a cast shadow here. So what is that cast shadow from? See how it only lights up that portion of the sky right there? And you notice how the shape of the light is coming up or by the sun as well? Or, yeah, all the reflection. Do you see why I say that these can't be our clouds? Because if they were our clouds, this would mean that this was closer to the camera than this is over here. Correct? Correct. And if that were the case, the sun would be up and we would see the sun lighting these up because these would not be lit up yet. Otherwise, there's no way they're next to the camera because we can't even see the sun. So there'd be no way they would be lit up like that, especially. Jeez. See the cast shadow? This is a cast shadow. The sun is not even hitting the lens yet. It's not up. See, the sun is being confined to this area. This one right here, this area, is closer to us, obviously, because the shadow and the not shadow and the reflection points, like it would be on the bottom of a ball. Now, as the sun comes up, everything starts to go dark. The sun will be the brightest thing in the sky. See? See? Dirt. No, and did you notice how these clouds got walked right into a shadow? See that? All of these clouds that are moving in this direction are falling into shade. Not even able to be seen hardly. That's not an anomaly either. Nor is the fact that the sun is going up around something right there. See how it's bending around the sky? See how this is no longer illuminated? This is down here, but it's below. See how the sun is pinching through there? See, these are our clouds. These other things in the background, they don't even go to the horizon. They just disappear outwards, upwards. You see which way they're going? Ignore the sun, ignore the glare of or the shadow from the edge of the housing. Just look at the clouds in the background. See how they're going up and out like they don't even belong here? Same with these up here. These move upwards and they disappear on an upward scale, on an upward push. And our clouds don't do that. Our clouds go from horizon to horizon. The further away they get, the lower they appear to be, not the other way around. That's not an anomaly either. See, watch this one. It just keeps going outwards and upwards. See? Same thing. You can see there's no light over here at all. You can see how the sun is even being shaded on both sides here. And you can see right here how it's going around just a couple of little clouds. Cast shadow. Sun is covered. Cast shadow still there. You can see the edge the sun is following. This is the crescent illuminated part of it. Cast shadow below, just like every day lately. And I say lately because it's not a normal thing. It's not an everyday thing. See, sun is behind a cloud, no more saturation, no more anomalies, and yet we have a big blurry area of sky. And there's one thing I've learned about clouds. Wow, that's really trippy looking. One thing I've learned about clouds is they're never blurry unless they're like rain clouds. But for the most part, when you look up and look at a cloud, they're crisp, they're clear, they're very focused in. You can see every little silver lining. It's the ones behind our clouds that aren't that way. They're blurry, they're hard to see, they're not illuminated. Probably because they're actually not part of the atmosphere. They're further away, hence the blurriness. You've seen them through space. Space clouds. Now that the sun is going down, it's starting to hit the bottom. How trippy is that? See how the light's still pinching across? See how long it stays there? Wow. Look at all that reflecting light. You can see the shadow all the way across the sky. It's subtle, and it's not like an eclipsing shadow. It's more like a cast shadow. An eclipsing shadow would mean something's real close, like the moon. Can't tell me you don't see this rounded cast shadow. That's not an anomaly. That is a true cast shadow. And speaking of the moon, I just want to point out a couple things here, because some people still seem to think there's a sun simulator up there. You guys are on glue, crazy glue, because you must be crazy. I know Dr. Claudia, or whatever the hell her name is, says there's one in orbit. Okay, well, let's talk about that word, orbit. The moon is in orbit around the Earth. Okay. Did you know that you could fit every planet in our solar system between us and the moon and still have about 4,500 miles of free space? Now, with that in mind, you think that we can put something in an orbit like the moon that would be that far away, because it would need to be that far away to illuminate the entire side of the Earth. The problem with that theory is man-made stuff in orbit is more like where the space station is. See, the moon is attached electrically to the planet. Its orbit's going to be a lot different. It was captured by Earth and turned into a moon. I'm sure it was just a rock going by at one time. Now, I've showed pictures of how close the ISS is to the Earth. That is the man-made orbit area. Anything beyond that is just going to float away and start orbiting the sun. Kind of like SOHO. SOHO orbits the sun 1,000,000 miles out in front of us. It's orbiting the sun. We're orbiting the sun as well. It's not in our orbit, it's in the sun's orbit. And I was watching a WSO once where this great big eclipse comes and just goes right in front of the sun. And what I thought was funny was Steve's thing was that the moon had passed in front of the camera. And that's what he was pushing. And that's kind of hard for it to do considering it's 1,000,000 miles away, the camera, and our moon is only 250,000 miles away. You see where I'm going with this? Because the guy that was complaining about the anomalies and the saturation also brought up that SOHO never gets eclipsed. That's not necessarily true. It has been eclipsed, and they can say it's our moon, but I just explained to you, this camera is 1,000,000 miles away, 1 astronomical unit from Earth. Our moon is only on an orbit of 250 to 300,000 mile orbits away from Earth. So there's no possible way that our moon got in the way of the camera 1,000,000 miles away. And I figured I would just say all this instead of writing it all down, because typing all this, I got better things to do than type. I'm too busy pointing out anomalies and saturations and camera malfunctions, he says. Well, I think I've expended enough energy on him. Debunked your debunk. Your debunk was for nothing. You can go copy paste it somewhere else. I'm sure you have. These cams are not bad. FAA cams, now, those are bad. Go pick on those guys with the flares and the glare and all that other stupid shit. And Sun Simulator. The Sun Simulator couldn't stay in orbit of the Earth. It would be as close as the ISS is, and the ISS is not big enough to light even 2 states if it were a freaking simulator. You guys don't seem to understand. The thing would have to be as big as the moon and further away than the moon to do anything in space as far as illuminating our planet. I mean, how would it keep up? We're cruising at a speed of 66,000 miles an hour around the sun. It would need to stay at an exact 66,000 miles an hour as we're cruising around our sun. Okay, I mean, that's as stupid as a kid with a magnifying glass, at an anthill beaming the light. It would just burn the planet. Any small error in this simulator, theory would do some serious damage. And flying along a planet-sized simulator at 66,000 miles an hour is about as ignorant as it gets. It's all fantasy. People don't even think it through when they're putting all their loyalty into something that's not really there. When did we build this thing? It would have taken 100 years. Have we been building it since the 1800s, 1900s? Come on. Anyway, thanks for watching, everyone.